at Apex 2026 in the Decode Podcast recording booth, 4813, for those of you keeping track of where we are. We're joined by Miles Moreau with Kick. He's the general manager, and he holds several international and U.S. patents, probably all centered around what you're most well known for, which is figuring out what's going on inside that thing we call the reflow oven. So welcome.
Thank you. Appreciate it.
So we have to get this out of the way because it's going to come up during this. You have one of the coolest parlor tricks in your booth right now. It's like a 1/10 scale reflow oven, fully functioning. That thing has to be getting a lot of attention.
Yeah. It worked out. We introduced the product at Productronica, and it was very successful. It really helps us to show how our systems are integrated into ovens. But you start to get questions about, how much is this oven? What's the throughput? all that sort of thing. But
how many people have installed this tabletop unit?
But it's really helped us because it's a realistic look, though a small scale of how our system integrates and what it can do. So,
well, I think it does a great job of it doing exactly what you've described. It lets you visualize inside the oven, and even though it's at scale, seeing how those sensors integrate into each zone. Talk to us a little bit about that system, right? So it's something that you can either get a new oven equipped with, or you can retrofit an existing oven to incorporate that. Is that correct?
Yeah, it's the nice thing on the reflow ovens, and we do that for wave solder as well, which is a little more challenging, but reflow ovens, from brand to brand and model to model, the basic structure of it is very similar. So when we look at embedding our system into those ovens, we can do it either through a channel through the oven manufacturer on a new oven and that gets built right in, or retrofit it. The sensors and the way we go about it are flexible enough and we've got actually, that's Kick's first product, was not profiling. It was embedding sensors and monitoring what's going on. So with about it'll be about a year and a half where we're at 50 years of having embedded systems in ovens.
And like we were talking about yesterday, the cool part is we can profile the board, right? We know the temperatures in the board, and we know the outcome of that profile, right? And then the ability with your system is to make sure that oven never changes what we set it to. And then with the product tracking parts, we can now see every single board. So if there ever was any type of issue, right, you can see, well, what did it look like through the reflow, right? And it's the same thing like we always talked about, like you can get an image now of the SPI, what did it look like after print?
Yeah.
You can get an image before it hit the reflow. Yeah. With the pre-reflow AOI, you can get an image after the AOI, but now we can also see what happened in the oven to cause that whatever deviation happened.
On a board-by-board level, right?
Yeah, and that's the thing, and that's an analogy I use all the time, is you have all this immediate feedback as the board goes down the line, but on the oven, a lot of people rely just on the oven, and you say when the oven changes, but every other inspection is looking at the product and
You've got detailed analytical charts and graphs. You're looking at this thing every which way you want, and then it gets in the oven, and you're just like,
the green light's on.
Yeah.
So
we're good.
Yeah. And that's kind of what you do is where you're looking in cameras, right? Because you're applying material, a physical thing. So you put cameras on that and say, was that applied correctly? Well, you're applying heat, right? There's no visible way of inspecting it. So what makes sense? Okay, embed something that tells you what's happening with the heat to your product, which is embedding thermocouples. You're going at a certain rate, so you track conveyor speed and you track the product through. And by doing that and modeling it with an actual original, your NPI profile, then now you have that data as each board exits. You can say, yeah, here's the profile it saw. All right. And then you're reacting the same way you react or proactive on how is that changing and do I need to do something?
I have like this age-old debate I bring up with a lot of people that specialize in reflow. And I've heard a bunch of different answers. And I think I know what your answer is. But I've heard contradiction from other people.
You'll get to the question momentarily.
Hold your breath.
You know I like to big foreplay, okay? You know that about me.
Yeah, you.
So, when you're taping your thermocouples, I've heard only use aluminum, only use Kapton. The PE, recently I was showing him how to do the profiling on the kick, right? Like how we use it, because he likes to actually use the ones inside the BTU oven, right? The ones that are attached to it.
Right.
But I don't want to have a 20-foot cable, right, like laying around my shop. So we're showing him, and then he put aluminum down first with Kapton over that. What is your opinion on that subject of what's the best practice for applying?
So I just recently did a paper which we had done probably close to 20 years ago on TC attachment because it's such a popular topic of conversation because it's challenging, and if you don't get that right, you can even our monitoring system can give you all the data in the world. If you didn't get that baseline profile set up right, it doesn't matter. With the attachment, all of those methods. Kapton we tend to stay away from because it
acts as an insulator.
It acts as an insulator. So wherever you put it over, even to help with the aluminum tape, you're deflecting some heat off. And the other thing on the Kapton, though, is the way the adhesive is. You always end up with some type of little air bubble around. It's not as malleable as aluminum tape, really getting the contact down. And so you're going to get a little bit of air temperature with your reading. And that's why on Kapton sometimes you'll see the squiggly line profiles.
Yep.
Now, because it does have an insulating property, I was suggested by somebody to use the aluminum tape like normal to anchor it down where you want, but then go further with Kapton tape over the top of that, and that will, if your only available option for profiling is a bare board with no populated components on it, but you want to get a closer simulation than you have with just the bare board, you can use that Kapton tape to kind of...
Meh.
Usually we say to use it as
Jerome know.
To hold down the aluminum and keep it secure, so like a window pane. So you just do on the edges around the aluminum tape and leave a window so the air can hit directly.
The issue with the aluminum is it doesn't stick as well as the Kapton.
Well,
it likes to pull.
Then it's to what type of aluminum tape. There is a variety. We were actually very selective in what we supply with our profiler, because some of our customers get like a roll of 3M tape. We got a aluminum tape, double-sided adhesive that's mainly used for thermal management, so for heat sink attach and everything. So its properties are to hold the heat sink on really well and be a good conductor of the thermal conductor. So that combination, even though you don't really need the double side, the properties of that tape work well for what you need to do to attach a thermocouple.
So your recommendation is aluminum only?
No, we've done epoxy as well. We've done some epoxies. The advantage of the epoxy is you get a permanent. If you have a dedicated profile board that you're going to be reusing, for a few times, then it's a good attachment method, and it's very repeatable. But if you've been delivered 500 boards worth of material and your customer asks for 500 back, you can't start using epoxy or high temp solder to attach your thermocouple. So then aluminum tapes, a very good and repeatable method as well. So then it's really down to, the pros and cons of each attachment method and what are your requirements as far as, can you waste a board, or can you ask your customer, deliver me 501 because I need a profile board? How often a customer is going to do that?
One of my favorite things about doing this podcast is the ability to talk to experts in the space and ask like genuine curiosity questions that I have. And I look at your product and I think, man, that thing lives a rough life. Right? I mean, it is just in the worst conditions day after day
Talk
after
about
day.
harsh environment.
How do you build those things to survive, and how long can they be expected to last in general?
Well, that's, I think, and when we do innovations and are looking at new sensing technology and everything, I think we'd probably have 10 times the number of products if it was all like consumer products at room temperature, where, the hottest it's going to be is, if you're out in the desert and it's 110 degrees, right? And there's lots of components because there's a big market for all that type of stuff. So all the materials are driven towards the biggest markets. So we always have to look for unique materials that like have that durability. It's becoming more and more available as more electronics go into automotive. There's a lot even in the energy industry where the downhole sensing technology for oil and gas, aerospace, they're very demanding environments for the materials, the insulators and the components or the electronics. So we're finding that there's more of it. They're obviously more expensive, but there's more things available now than, say, 20 years ago, where you can find things that can withstand that. But that's a big challenge when we're developing even just a simple data logger. It's not coming up with a data logger. It's coming up with a data logger that, like, can get beat the hell out of and cycled through up to 300 and back down,
It's a
200
rough
times.
Well, actually, that happened to me the other day. I didn't select one of the options on Start Profile.
That's the worst.
And then
you run it.
I ran it through.
You're like, let me plug it in or whatever. It's,
And then it came out, right, and it was at like 35C, right? And I'm like, then it needed to be down to like 23, which is like our room ambient, 22, somewhere in there.
Yeah.
And I was like, come on.
And that's where the next step comes in, is where automation reduces the amount of time you have to profile, right? So if you are profiling frequently, either to validate your profile or you have a lot of new products coming in, then if you automate that, where you use the profile, like you said, as a baseline, or you're programming a system, and then that embedded system, which is embedded sensors that can handle the heat, and then they're static, they're just staying in there, then those systems that we have usually last longer than the life of the oven. So now we have a system that you don't have to beat the hell out of your profiler. You have an automated profiling during production, and then, then the value of that becomes a lot.
I didn't even think about that. The one that's in your peak zone is going to be at peak all day long, right? Like that sensor is in peak all day long. That thing's going to take a beating,
And well, that's when I say our first system was monitoring. Our first systems we did were in microelectronics, hybrid ceramics. So they were in furnaces that went up to 1,100 degrees.
LTCC stuff.
Yeah. So we got really, so our systems now in reflow, that industry is still there, but we're not as involved with it. But when we had a high temp system, medium temp, and reflow for us was our low temp system. So 450 and below is low temp. So 450
that's
below.
That's the easy stuff.
That's the easy stuff, yeah. So that's especially with everything going where more automation, more AI embedded in stuff. Our system, which we've had for decades, fits right into that value proposition.
So I am lucky enough to have the Wi-Fi. I can watch it on screen as it goes through, right? Can I make a user request?
Absolutely.
Wi-Fi thermocouple. I don't have to attach it. Then there's no tape. I don't know how you do it, right? Because you need to probe something, but it's just a user request. So
okay.
It's been submitted.
That is, as soon as they make something in Wi-Fi that can go up to 300C
Well, we have
without insulation, now that's something.
we have our meters, right? That we could use
Yeah.
Wi-Fi to measure the temperature of the steak or the rib roast or whatever. But I don't think that's quite
I think
300.
those are only 500 Fahrenheit, right?
Yeah, well, we're a little far away. I think this is a really interesting subject for a lot of our listeners, reflow and profiling. I want to give them a takeaway or two. So maybe like one, never do in terms of a reflow profiling practice, and one, always do. Give us a do and don't on reflow
Ooh,
profiling.
on the spot.
On the spot.
Okay, I'll do the.
I got a don't.
Oh, he's got a don't. I was going to start with the do.
Okay.
I would say the do is to run a profile on every assembly, because we have a lot of customer, and even with an experienced engineer, you can say, I know I can look at this board. I've done a board like this before. This is the settings, and then run it.
Yeah.
And then you get, okay, it passed inspection, passed test, but you don't know how good a solder joint that is. You just know it passed inspection and test. That doesn't tell
looks
you that
good
it was
visually.
that does, yeah, visually, maybe electrically, but did the solder paste and the other materials go through what they were supposed to go through? Because somebody else tested that part. The solder paste manufacturer said, we know from hundreds of tests that if you put it through this temperature range, that it'll melt correctly, you'll get the intermetallic layers that you want. But if you just do that, this is close, then all you're guessing on is the mass, the distribution, and kind of the density, but that's not going to tell you. So, I mean, the do is, I mean, that's the biggest thing, is actually run
Actually
the
do it.
profiles. Yeah.
Did
I'm curious to hear
Did you
Sean's
want to give
don't.
the don't, Sean?
Don't put the profiler through the oven until it's running the profile. Because then you have to wait for it to come out and cool down.
And the length of some of these ovens, that might be, I mean, just waiting for it to
It's
come
just
out,
so
right?
depressing because you're like, no, and then once it's in zone 1, you're like, too late. It's too
Yeah.
late. I can't activate this now.
Well, that is a don't too when you're doing iterations, is and our software tries to catch that, is if you're just trying to get something done quickly and you don't wait until the board gets down to room temperature. What production board starts going into the oven at 50 C?
Yeah.
Unless you have an outdoor manufacturing line, then maybe you have that. But
Yeah, in the Saharan desert.
so that would be one don't, is, you the don'ts are, or more do's, is make sure the behavior and the characteristics of what's happening of your profile are the same as that
It's got to be
production.
truly representative of the
Yeah.
process, right?
Yeah.
Well, if people want to keep up to speed with what Kick's got going on, how do they find you? How do they contact you?
At the show, we're at booth 2702. We have our great. We're now competing in the oven oven space.
The Micro Reflow world.
Micro Reflow.
And otherwise, kickthermal.com. We have a vast number of information on our site and also on our YouTube channel, which is the same name. A lot of tutorials, how-tos,
New
do's
software.
and don'ts.
New software can be downloaded on the website too, right?
Yeah.
Yep.
Awesome. Well, we really appreciate your time and Kick's support of the podcast, and I learn something every time I talk to
every
you,
time.
and I think the guests do too. So thank you so much, Miles, and thanks for tuning in.
All right. Thank you.
Nice.